Hello guys. In this video, we are going to talk about how you can go from a set of data like this one in this table and come up with a function or an equation to model that data. So what I'm using right here is this table is the number of coronavirus cases in Belgium. I know you care a lot about Belgium. I do too, but this goes back 14 days. So this is 2 weeks worth of data for them on how many cases of the coronavirus they have. You guys collected this data for Ohio and for Cuyahoga County over the weekend. So this is as of today, but I'm recording this on Friday. They had 6,000 cases, way less than we have in the United States. And if you go back 2 weeks, they only had about 400 cases. So I went and painstakingly already plugged in this table. So you'll notice as of right now, I don't see anything showing up on my graph. So what I need to do is, well, right now my graph is only going up to 20. That's nowhere near high enough, right? Now my X is fine. My X really only goes up to 14. So in fact, I'm going to zoom in a little bit with my X. There we go, because I don't need that to go any higher than 15. But my Y, I need to change that. So I'm going to come up here and click on this wrench. Here it says Y-axis, so I'm going to change. It tells me what the smallest number is, -10. The biggest number is a little bit more than 12. I need it to go way higher. I need it to go beyond 6,000. And I like to make it a little bit roomy, give it some extra space. So I'm going to do 8,000 here. Now I'm going to close this wrench, and there we go. Now I can actually see all of those data points that I had plotted. And does this look like an exponential curve? Now it's not going to be perfect, right? Because there's always going to be issues with collecting data. There might be some people that just don't get tested. There might be issues with we didn't have enough testing kits. But this does roughly look like an exponential equation. So what we're going to do is we're going to come up with an exponential equation, and we're going to try to get it to match up as perfectly as we can here. I'm going to change my graph to projector mode so it's easier for you to see on the video. So remember, our exponential functions always look like this. F of x equals, there's going to be some number there, your initial amount. So what is our initial amount here? Well, on day 0, we had 399 cases. So 399 times. Now maybe it's doubling. Let's just take a guess. Let's put a 2 here for doubling. And then we're going to put to the power of, and if you don't know how to get your to the power of, click this button. It's this one right here. And then put your x there. Okay. Clearly, my equation that I just wrote is increasing way too quickly. So it doesn't seem like it's doubling every day. And we can tell that just by looking at the numbers here. We're definitely never going to change this 399. That's always our initial amount for sure. But let's try, maybe it's going up by just a percent. Like maybe it's going up by 5%. So that would actually be 1.05 here. All right, now that's too small. So I'm going to try, maybe it's not 5%, maybe it's 50%. So I'm going to put 50 here. Oh, it's still too big. Okay. I'm just going to sit here and I'm going to experiment a little bit, see how close I can get it. Well, what about 30? Well, it's still too high, but we're closer. 25? 25 actually looks pretty good. I still think that it's a little bit too high. I think that's a little bit too fast. So what about maybe 20? It's not bad. 21? Ooh, I like 21. Okay, I like 22 even better. All right, so this is my final equation then. So I'm going to say that I can use the equation or the function f of x equals 399 times 1.22 to the power of x to model my set of data. And we're going to talk about why people do this. People use equations to model data all the time. And it makes it really easy to make predictions and analyze the data and things like that. So your assignment today is you need to do this twice. You need to do this for your set of Ohio data, and you need to do this for your set of Cuyahoga County data. So you have 2 things that you're turning in. Here's how you need to turn it in. So once you are done with all of this, you've drawn out your data, you have come up with an equation that you like, you're going to come up here. It's going to say untitled, and you're going to hit save. Well, actually, you're going to click on this. If you try hitting save, it's going to pop this up and it's going to say, hey, name your graph. So you're going to name it whatever your last name is, Badnars. And then you're going to label it which set of data it is. So you would say Ohio data, if it was Ohio. You're going to hit save. And then now that it's saved, this URL is going to take you back to this graph. So you can always get back to this graph later on as well. So you're going to submit this link. That's your answer for your Ohio data. So you're going to do that twice. Then you're going to do your Cuyahoga County data. So you're going to do last name, and you're going to say Cuyahoga. Try to spell that word right. That's your extra challenge. Cuyahoga data. You're going to hit save. Okay, now you've got a link for your Cuyahoga data. You're going to copy it, and then you're going to paste it. That's your submission for your other one. Okay, I have a little bit more data for you guys. So as your homework, you found the last 3 blocks of this table, but I'm going to give you guys going back all the way to these numbers right here. So we're going to use this as day 0, and you're going to go all the way up to, and in fact, if you add today as well, if you're doing this after 2 p.m., then you can get even one more data point, and your equation will be a little bit more accurate. All right.